This tractor just does not look right with this exposed battery compartment over here. There should be a cover over that. I found this picture of what an original battery compartment cover would look like. Now this one is in very rough shape. The tractor we have did not have one on at all. And then over here is a picture from the parts book of what one should look like. As we continue to make some improvements to this tractor, the exposed battery compartment is on the list of things to improve. It has been bothering me and it needs to be fixed. So we're going to measure, design, and fabricate a new compartment door. And we're going to try and get it to closely resemble the original one. So the tractor here is a white 2-65. I've had it in a few other videos if you want to check those out as well. Thanks for tuning in, everyone. If you're new to this channel, my name is Steve, and I would greatly appreciate it if you would subscribe to the channel. And if you see something you like, please leave a thumbs up. I hope you enjoy. Here's our battery compartment in here. There should be a cover over that bolts here, and then 2 places down here. I tried finding one. I put a few inquiries out. Nothing turned up, so we're going to try and make one. So what we need to do is we need to measure this area. There is a bend here. We got to create that bend, and then there's 2 tangs, like a bent piece of metal spot welded onto the vertical part here. So we've got to create those. And I don't know if you can see here, I already had to make a battery hold down bracket. It's kind of an eyesore without having that compartment door on, so we want to put that in there. What I was originally going to do was take an 1/8 inch thick piece of sheet metal, bend it around, and basically weld on some tangs. And while that would have worked okay, I actually had cut the piece of steel out already. If you look closely at this, you can see how it's kind of bent around here a little bit. Now this is thin, maybe a 1/16 of an inch, maybe a little bit thicker. So we're going to actually try and replicate that. I don't have a press brake, but I am going to, this is about a 1/4 inch here, but we're going to measure it to make sure. We're going to make something out of a 1/4 inch piece of steel. And we're going to mill the backside to hollow it out. So that'll kind of replicate this edge here. And then we'll put this radius on here. So we should end up with a very similar looking compartment door. So let's get some measuring tools and try and figure this out. So we want to measure about how thick this panel that sits next to it, how thick that is with that flange on there. So yeah, it is right about at a 1/4 of an inch. So we're going to start out with a 1/4 inch plate of steel, and actually I'm going to measure I'm going to look at another plate of steel here, figure out how thick this is. I'm assuming this other one's probably similar to that. Just by feel, it feels the same. So that's about 3/32 of an inch. Now there is a radius on here, and we're going to try and measure that with some radius gauges. So I have this set of gauges here. They're all different size radiuses. If you look, you've got like an internal, external, full radius or half radius. So you got all these different, like this example here is a 5/16. You've got all different sizes on here, and you can just maneuver this gauge to try and determine what radius you have. So it looks like it could be about a 1/4 inch radius, maybe a little less. Let's try a 7/32. See how that looks. I'm going to have to bring you in here a little closer to see what's going on. So here's what we're trying to replicate here. I would say, no, that's pretty close. That might be a little bit big yet. Let's go down to a smaller size. Let's try 3/16. I don't know how well that shows up. I'd say that's really close. So we're going to go with 3/16. Just going to jot this down on our paper. Now we've got to try and get a measurement of the width, and then it's going to be a little difficult. We got to figure out where this bend is and how these two intersect. and at what angle this is. So we're going to put this protractor on here. We're going to try and determine our angle. Okay, so that looks like a 30-degree angle. Yeah, that's showing 30 right on. So I'm just going to jot some stuff down on the paper here a minute. Now we've got to try and measure up from here to where this bend would be. What I'm going to try and do is just take my straight edge here. I got to grab a light. It's kind of dark in here. So if we measure up from here, I'm setting this right down on the existing platform. It looks like right to that bend point, it's a little under 8 5/8. So if I lift it off just a little bit, we're going to call that 8.5 inches to the bend point here. Actually, I'm going to grab a little marker and just put a mark on that. So right here is about the center of the bend. Now we want to come up this way. We want to stay away a little bit. Looks like 2 5/8. 2 5/8 might be a little much, but if we have a little too much on, we can come trim some off the ends later. But we want to get it pretty close because we're going to hollow out the inside of this 1/4 inch plate. So we don't want to be too far off. Calling it 2 5/8, but I'm writing it in decimal form. You know, I didn't write our other number on there. I've also got to write our 8.5. Okay, let's measure twice, cut once here. So, yep, still 8.5. Now we want to figure out our width. So I'm going to measure not right to the fender, but to the edge of this console here. And of course, we want to leave a little gap. I don't know how much was originally there. So to the edge of that console, I'm going to go with 7 5/8. Well, no, actually, I guess I didn't see this. We want to go about to the edge of the console here as well. So we're going to make it the same width as this. Let's go 7 9/16. Now we got to find out where these holes are. So yeah, we've got to figure out the spacing here and then how far down from this console. And then there are the 2 holes here. We've got to figure that out. I'm going to have to come back later and try and measure that more accurately. But we have enough now where we can start cutting our plate out and hollowing that out. So we'll come back to measure this in a little later. Oh, and one more thing I forgot. I think we'll try and put a radius on the corner of our plate too, and we'll get it similar to what this is. So I got to come back and figure that out a minute. We're going to take the radius gauges out again. Well, it's a little skewed here. I don't think I have good light here, but this is about a 5/16 radius, so that's what we're going to roll with there. So we like to try and get a pretty accurate location between where I have to put these bolts in here. So I'm going to thread in a bolt. Those are metric size, and we're going to take a caliper and measure to the outside diameters of those bolts. Then we're going to measure the diameter of the bolt and subtract that, and that should give us our distance. So I found some metric bolts. They measure about 0.310 inches, which is actually pretty close to 5/16. Just going to thread those in, and we're going to try and get a measurement across here. A little hard to get in there, but it looks like about 5 inches 405. If I subtract 0.310, that's going to put us about just over 5.1 inches. So we're going to call it 5.1 inches. And then looking down on these bolts down at the bottom, I would assume that's also going to be 5.1 inches. Just by scaling it, it looks to be pretty close. So we're going to call that at 5.1 inches as well. So we're going to get that written down on our paper and then go back, and I may draw this up on CAD after I have a rough sketch of it so we can just visualize it a little bit better. This is the 1/4 inch plate we're going to cut our piece out of. We're going to take it, we're going to move over about 8 inches here. We're going to cut this off, and then we're going to put it up in the mill and mill out the pocket. So we're going to go over to the bandsaw now and get this set up to cut out. So now with our main plate cut off, it's still about a 1/2 inch too long this way. So I'm going to set it up again in the bandsaw. We're going to trim that off. We're going to go over to the milling machine and start squaring it up. So with our plate cut out, I now went ahead and marked some stuff off on here with a marker. The areas where I have slashed out here, we're going to make, we're going to pocket this area out. So this plate is a 1/4 inch thick. We're going to mill down about 3/16 of an inch, approximately where it's slashed in black here. And if you see here, we've got some lines drawn here. This is about where we got to have the bend in the metal. And I don't have really the proper equipment to bend that nicely, especially now that it's going to be pocketed out. So what I'm going to do is take an 1/8 inch cutter. We're going to cut a slot through here. Now some of this will be cut away already, but we're going to cut maybe halfway through or maybe a little further than what metal we have or what thickness we have left here. So we're going to take out a 3/16 of an inch here, all through here, and then we're going to go an additional maybe 50 thousandths below that, and with a ball nose end mill. And my hope is there that once we get that cut out, I'll be able to maybe put this in a bench vise or put it in my press, and we'll be able to make a nice bend on there because we'll have a nice witness mark through here. So that's what my hope is. And we've got to go through, we're going to use our radius gauges, and we're going to go over the disc sander. We're going to put this radius around all 4 ends here. And then when we're over in the mill too, okay, now this will be our show area here. So now we want to roll a radius around the edge, all the way around the perimeter of this part. So we're going to take a rounding cutter here, and we're just going to mill all the way around it. And then we'll have our nice radius formed on the edge there. So right now we're going to go over to the mill. We're going to clamp this down, and we're going to machine all 4 sides square to each other. And then we're going to get it to the correct length and width. We've got our piece clamped up on the milling machine. I just have 2 clamps on here. I have these stops pushed into the T-slots on the table. They're a snug fit, and these T-slots are machined in there parallel to the direction of the table. So when they're in there, I just lightly push this up against these stops, tighten it down, and now we're going to cut all 3 edges here at one time. Being that this edge is a little further away from the clamps, if it tends to chatter when I'm trying to cut this, I may come into the side with another clamp and clamp that down. But I believe this is going to work. Now, being that the work piece is also way out here, I got to make sure that I have enough travel in this direction to cut that in one pass. If not, we're going to have to move the ram on the mill to do that. So the plate mounted up in the milling machine, I wrote down the length we've got to have it at. It's 11.254, which is basically 11 1/4 by 7.562 wide. So we're going to machine that up now. Okay, now we've got 3 of our sides cut. We've got it cut to length here. We got this edge done. Got this edge cut. So we're gonna unclamp this plate, turn it around, and then we're gonna mill this what's on the back side now. So now we're gonna cut this final edge here. That'll establish our width, which has got to be about 7 9/16 wide. So now the next step, I'm going to take this plate off of here. We're going to bring it over to the workbench, and we're going to take the disc grinder and take all the sharp edges off around the perimeter of this thing. And then I'm going to flip it over, and we're going to, well, even before that, we're going to put these corner radiuses on all 4 corners. I think it was a 5/16 radius. And then we're going to flip the plate over before cutting the inside of this out. And then we're going to put I don't know if it's a 3/32 or 1/8 inch radius all the way around the perimeter. And then we'll flip it back over again, and then we're going to cut our pocketed area out. Now we're going to put these corner radiuses on. I'm going to just put some red dye in these corners here. And then we're going to hold up our radius gauge, and we're going to scribe a line on there and take it over to the disc sander and form those radius. Okay, so we got our 5/16 radius gauge. I'm going to push this up into the corner. Take a scriber with a sharp point on. Just going to etch that in there. Do that on all 4 corners. So with our plate set back up in the mill, I've got this set of radius cutters here. I actually just bought this used off eBay. I think they're pretty good quality. They seem to be sharp, and it looks like most of them say they're made in Spain, although some of them I don't see. But anyhow, I decided to use the 5/32 cutter. I think I may have mentioned either 1/8 or 3/32 before, but so what we're going to end up doing, we're going to touch off the side here, and then we're going to touch off the top here, and I know how far to move over. I did some measuring and figured out how far we had to move over with this particular cutter. We're just going to run it along the edge here again, flip the plate around, do that, and then actually we're going to run it along the edge and then do both these ends, and then flip the plate around and do that edge there. So let's swap this cutter out, put this one in, and start cutting. So I'm going to clamp the plate down now, and then I'll touch the cutter off on the sides here. So I've got I believe it's a 2000 shim here. I'm just going to put this underneath the cutter. We're going to slowly bring the table up. We're going to touch off on the end of this cutter. Again, this isn't super critical. If we're within a couple thousandths, it's fine. So I'm just going to move this thing until I get a good drag on it. Okay, so I know we're about probably about 2 thousandths away. I'm just going to zero it out here on the digital readout. Lift it up a little bit. Now we're going to come over and touch the side of this cutter off. Again, I'm just going to move it over until I get a drag on this shim. I'm going to zero it out. Okay, so now the bottom of our cutter is touched off on the top of our plate here. And the side of the cutter is touched off on the edge of the plate here. And then I've got some dimensions here on how far we have to move over. To get the full radius on there, we got to move this down 0.169. And then over In the Y direction, 0.219. So we're going to stay just a little shy of that, and we're not gonna take it all in one cut. We're going to put some cutting oil on. Okay, we're barely taking anything. I'm going to back it up and move it over some more. So here's our first pass cut. We're a little ways away in the Z and then a little further away in the Y direction. So I don't have a lot of experience using these cutters. I kept the feeds and speeds pretty slow. This is not a carbide cutter. So we're going to creep up in our Z and in our Y and get real close to where the finished size should be. And I'll probably just leave it at that. And I'll bring it back when I'm finished with the next cut. So I took our finished pass. We have a really nice radius on there. I think the cutter works really well. I don't know how well it shows up on the camera with the lighting, but yeah, very pleased with the way it came out. So I'm going to go ahead and go along the outer two edges here, and then we're going to flip it around, do the other side. So I'll bring it back after all that is finished. So we have the fillet cut all the way around the perimeter of our plate. I'm now going to flip it over, and we're going to center this on the table. Right now it's offset because we have it up against these stops, but I want to get it centered on the table because of after flipped over, we have to pocket out this entire area here. So I just need to have these clamps right close to the edge. And then another thing we have to do, we have to put 2 holes in for mounting where those 8mm bolts have to go through. And then one thing I didn't show you, there are these little brackets that have to go on here. I've already made these up. They're just basically a right angle bracket. I actually made it out of this plate of steel here. This was pre-bent already, so I kind of repurposed this into both of these. They're mounted here, approximately here, and from what I can tell, they were originally spot welded on. So I'm going to drill a couple small holes through this plate, and then we're going to spot weld these on with a TIG welder. And it's possible I might weld along the bottom here too. And I probably didn't have to put this fillet along the bottom, but I did. Now we're using the edge finder to find the center line of this plate in both X and Y directions. And then we're going to reference our hole locations to our plate center line. So I have the center line of our plate picked up, in this direction. Then I have the edges referenced from these 2 edges, and we're going to put in, we're going to spot drill, and then we're going to take an 11/32 drill. It's like a clearance drill for an 8mm bolt. We're going to put 2 holes in, and then we're going to put 4 maybe 1/8" holes in for our an area to spot weld our tabs on. Now we've got our holes drilled through the plate. These are our 2 mounting holes, and then here's our through holes to spot weld the tabs on. So I'm gonna unclamp this now. I'm gonna reposition the blocks underneath further out to the edge, and I'm gonna put 4 clamps on. We're gonna get them clamp them right at the very ends of the part. So I'm gonna set up and do that now, and then we're gonna find the center line of this plate. And we're going to prepare to mill a pocket in here. I'm going to put a roughing cutter in there, and we'll mill that out. But I'll bring you back when I get that set up and ready to go. Okay, so now we're set up and ready to start cutting the pocket into this plate. I've centered it in both X and Y directions, and so we're gonna plunge the cutter down approximately where there's a hole already, and then we're gonna cut about an 1/8 inch deep, maybe a little deeper. And we're going to first run around the perimeter of the part, and we're going to go use the digital readout to get our correct spot. And And then once we have the perimeter cut, we're just going to go weave back and forth, and we're going to take the full depth of cut at once. We're coming up on our final pass. Okay, so we have it all pocketed out now. One of my concerns was that it was going to warp a little bit after we removed all this stock. And I did lay a straight edge on here. It did warp a little bit, maybe 20 thousandths, a ½ millimeter. It shouldn't be a problem though. So now we're going to come back. We're going to put an 1/8 inch cutter in. We're going to move over, I can't remember, about 2.5 inches. And then we're going to make some passes across here. We want to cut a groove in here. That's where I'm going to try and bend it. So hopefully we can get that bent without using the shop press, because I don't really have a fixture to do that correctly in. So let's switch cutters and go to town cutting that 1/8 inch groove. So we got an 1/8 inch cutter up in the collet now. We're gonna run this cutter back and forth, cut through this wall, and then we're gonna do the same on the other side here, cut through that, and then we're gonna cut into this main body here. So we're gonna try and leave about, I don't know, 40-50 thousandths thick of steel there, and hopefully it'll bend nicely in that groove. Okay, so we got the slots cut through on either side, and I'm going to run all the way across. We're going to cut down about another 40-45 thousandths, and that's going to be the track where we bend it around. Well guys, we have the groove cut in there now. So I took some pretty light passes. I cut about 5 thousandths deep at a time, ran it pretty slow. It's an 1/8 inch carbide cutter, so it's fairly fragile, but it seemed to have cut well. I cut through about half the thickness of this area here. What I'm going to do now, it's going to take it off the mill. We're going to deburr the sharp edges, and I may put a chamfer over here because this has to bend, and as it bends, I don't want these things to close up. And then I'm going to walk it over the tractor and check the fit up in this area. It's possible I have to have to come in with a smaller cutter and clean this corner out a little more. So if it does look like it's going to fit correctly, we are going to try and bend it. Now I think what I can do is put some supports on either side of this. I'm going to put it in the bench vise, and I should be able to just pull it over by hand. And I think we had to have it about a 30-degree angle. So I'll check it with a protractor as I'm bending it, and then let's go over to the tractor and see how it fits. So let's pull it off the mill and start deburring it. So here we're trying to test fit the plate on here. It looks like everything's pretty close. However, this tab right here, it is hitting on the corner of the area I thought I may have to clean out. So we're going to have to come and pick that out with a smaller cutter. Try and make that fit better. So I had taken this over to the mill. I did this off camera, and I milled some out of these corners here. I used a 1/4 inch cutter and just picked that out. And then I did bring it back over to the tractor and test fit it again, and it seems like it fits nice now. So we're going to now set it up in this bench vise here. I want to try and clamp these hardwood boards on either side and into the vise, and then we're going to try and bend this large part by hand. We've got to have it at a 30-degree angle. So I have the protractor ready. Not sure how well that's going to work. If that doesn't work out well, we may have to try and make a fixture of some sort and put it in the the press over there, the hydraulic press. Okay, let's give it a tug here to see what happens. Well, it's bending okay. Let's just do a check and see what angle we have. I'm going to have to pull it out of the vise to do that. Yeah, we've got to go a bit more yet. I'm a little concerned about our corners in here. I might be close. I may just clear them out with a grinder just a little more because once I find out if I do bend it and I'm not far enough, I got to try and bend it back again to get in there with a disc sander. So I don't want to do that. So we're going to clear out just a little more in these corners. And once this thing is bent, I'm going to try and take the TIG welder and fill this back into the weld. That'll give it strength from bending again. And then and then we can kind of blend that out to make it smooth transition again. Okay, guys, so that's right at about 30 degrees. Now we're going to have to take it back over to the tractor to do a test fit. Just to make sure we don't, in case we have to tweak it some. Okay, so it's the next day. We're going to cut down to the barn. We're going to take our cover over there and do a test fit. I'm going to attach it to this magnetic base. That's just going to make it a little easier putting it in place. So I've got our cover put in place. I put the 2 bolts in here. I got to say my first impression of it, it fits really well. We are going to make a couple little adjustments. Kind of hard to see here, but I'm going to take maybe cut an 1/8 inch off the bottom of this. That might allow it to drop down just a little bit. I mean, our gap could maybe be a little bit greater here. And then I'm trying to get a little better lighting in here. A little hard to see where the tabs, I do not have them welded on yet, but they're a little bit off on the bottom. And I could pull that plate out and it would match in there, but then it's not quite flush to the existing sheet metal. So I may slot those mounting holes out just a little bit, and I think by the time you put a bolt with a washer in there, it'll cover up the slotted area. So yeah, I think it's looking really well. We're going to just make a few tweaks to it. We're going to weld the tabs on and then paint it up. Okay, we're set back up in the middle again. And we're just going to run a cutter across here. We're going to take about an 1/8 inch off the bottom, off this edge here. That's just going to allow us a little more clearance on the bottom. Basically, when this is in place, it's setting right on the platform sheet metal. I just want to give that a little clearance, so we're just going to mill it off a minute. Okay, I mentioned a little while ago I was going to slot these holes out a little bit. After I refit this back in, after trimming that 1/8 inch off the bottom, found out I really didn't have to, but just in case, I did open these holes up with a drill bit a little bit, and then I went ahead and did the same here. It really wasn't necessary to drill the holes out. It would have worked okay, but if I felt that I needed to do it just to make some adjustments, I'd rather do it now than after it was painted. So now what I'm going to do is I'm going to scribe some lines on here, and we're going to, just so we know where to clamp these things, we're going to clamp them on, and then we're going to spot weld them with a TIG welder. So I'm going to put some layout dye on, and then we're going to go over to the surface plate and lay some scribed lines on here. This height gauge here is read by a vernier scale here, so it takes a little focus with the eyes to read these, but they work quite well. So the tip on this scriber is made out of carbide, so it works really well. So I'm going to measure to the top here. We're going to divide it by 2, and we're going to take our measurements from the center line. And then I'll just probably flip the plate to get one side to the other. Okay, we got our scribe lines on here. That's where we can now mount our tabs within those scribe lines, and we should be in the correct location. Okay, now we got to try and clamp these on here, and I got to try and leave room so I can still get in there with a TIG welder. Okay, now with these clamped into place, we're going to flip it over. I'm going to clean this die out of there a little bit, and we're going to try and just spot weld that together with a TIG welder. And then I'm going to come back and fill in this with TIG weld as well, and maybe along top here. And then we're going to come back, smooth that all out, and might come back with a sandblaster just to hit these areas a little bit, and then we're going to be about ready for paint. Okay, we got them spot welded on. Well, we got it welded up, guys. The spot welding went well, and then I went to weld these edges back in here, and the very first one went okay, and then went to the other side, and for whatever reason, I could not get it to weld good at all. It just seemed like the head here, there's gas flowing through there, and almost I do have a coolant leak here, but it just seemed like the gas coming out of there was not shielding it properly. So I messed with that. I tried a different tungsten, I tried different ends, and I don't know, it just was not going well. I did, however, get it. It's not real pretty, but nonetheless, it will work. I just got to grind this back off. But yeah, we should have been able to get a nicer finish in there with a TIG, but for whatever reason, we're having issues. We got to get that figured out. So with our welding complete, we're going to come back and touch up these areas with a grinder and remove some of that weld and form it back into the plate again. Okay, we got our weld sanded down, smoothed out again, both on the outside and then on the inside, roughly. So I'm just going to bring this over to the blast cabinet. We're going to sandblast around these tabs I welded on the outside and then the inside. And then we're ready for paint. Well, we've got it sandblasted and cleaned up. We're gonna hang it by some wire, and we're gonna begin painting. We're also gonna paint some of these bolt heads here that holds it down. Well, guys, it's a couple days later. The paint is dried. I also painted the bolt heads here, so our cover is ready to be put back onto the battery box. I'm really happy with the way it turned out. We've got a pretty nice cover. It's probably stronger than the original, with our extra thick edges here, and we still maintain a 1/4 inch on the edges, and it thins down to about 3/32 of an inch. So let's go over to the other barn where the tractor is, and let's get it installed. We're back down by the other tractor now. One thing I did want to say on the back side of this battery door here, it looks like from looking at the parts manual, there may have been some kind of a foam pad put on this plate, and then when it was installed, it would be kind of up against the battery. It's not really necessary, but I may come back later and try and find a pad to install on there. It'll probably work out nicely. It'll fit down in this recessed area. So we'll look into that at a later time. But for now, we're just going to bolt it in place and see how it looks. Well, it sure is nice to see that battery compartment covered up again. Really happy with the way it turns out. Of course, obviously our new paint doesn't match our old paint, but it still looks nice overall. Thanks so much for watching, everyone. I hope you all have a very Merry Christmas and God bless. As a side note, here's another part I made but didn't make a video out of it. It's a PTO cover. Now, it's a little bit different than what the original would have been, but nonetheless, the original would have had more rounded corners here. So we're kind of getting a reflection off their light up above here, but I used part of what was original. This stamped piece of metal here was originally still mounted to the tractor. It was just spot welded onto a larger piece. It looks like something had gotten caught in one time and ripped the original shield off. So I fabricated a new one, which is probably a little stronger than the original, and reattached it by spot welding it back onto our new shield.